As Mr. Bowman here, today's learning objective is in orange. We are continuing to learn how to apply F over T to determine the probability of given events. And today we're going to have the help of tables. And I'll show us what I mean by that in a little bit later on. So the first thing we're going to have a look at is the scenario. So we've got two boxes, and each of these boxes contains some random numbers. And all the odd numbers are going to be put in box number 1, and all the even numbers are going to be put into box number 2. And what's going to happen is you get to pick one from each box. So one from each box, but the only issue is it will be random. You don't know what number that you are going to get. So the first question that you're going to be considering, and it's sometimes referred to as the sample space. So sample space, you need to think about all of the options that you can pick. And the way I want us to do this, the way I want us to think about these are the use of a tables. So let's have a look. We're going to draw a table down here and down there. So we're going to call this box number 1 and this box number 2. So box number 1, we're going to use the side of this table to put down all the options that could come up for box number 1. So we could get number 1, we could get a 3, we could get a 5, we could get a 7, and we could get a 9. So we could get any of those from box number 9 or box number 1. And then box number 2 is the same. So up the top here, box number 2, we could get any of those even numbers. So we could get 2, we could get 4, we could get 6, we could get 8, and we could get 10. And from here, we're going to populate our table with all of the combinations that could happen. So this first position here, so that there relates to getting a 1 from box number 1 and a 2 from box number 2. So that there is going to be a 3. The space over here, that's going to be a 1 and a 4, and combined, that there gets us to 5. And then we're going to carry on. That there would be 1 and 6, which is going to get us to 7, and then that there would be 9, and that there would be 11. We're then going to repeat the same for the next number. So this position here would have been a 3 and a 2. They combine to get 5. And by completing this process, we would get every combination of numbers possible from drawing a random number from each of the two boxes. So there's 7, that's 9, 11, 13, and 15. And then we've got 9, 11, 13, 15, and 17, 7 plus 10. And then the last one, we've got 11, we've got 13, we've got 15, we've got 17, and we've got 19. So as you're filling it out, some of you might have noticed a pattern. So the diagonals, so there are the 5s, there are the 7s, there are the 9s, then we've got the same for 11s, 13s, 15s, 17s, and 19s. A whole bunch of patterns. So these here represent all of the possible combinations. And if you have a count, there's 1, 2, 3, 4, 5 in each row, and there's 5 rows in total. That means there are 25 different options that you could get when you pull these random numbers out of that. So there's 25 in total. So let's have a look at some actual probability questions, and let's ask, well, what's the probability of getting over 10 points, or a combination of 10? And I want us to write the same. So probability of 10 or more, I'm going to write 10 plus. We always are going to use this F over T approach. And we know that T is going to be 25 because there's a combination of 25 different numbers that you can get. And of these 25, we now need to figure out, well, how many of them are over 10? And we've then just got to count. So we've got 5 11s, 4 13s, that makes 9, 3 15s, that makes 12, 2 17s gets us to 14, and then 1 19, which gets us to 15. There are 15 out of the 25 combinations are above 10. And we can simplify that fraction to 3 over 5, or we could convert that to a decimal, which I encourage you to do, 0.6. We can then have a look at another scenario. Well, what's the probability of getting exactly 7? And then same thing, probability of 7. And we're always going to use that F over T formula. We know that there is a total of 25 because there are 25 unique combinations. And if you have a look at the table, 3 of them meet that criteria of being a 7. So that there is going to be 3 over 25. And if you put that in your calculator and convert it to a decimal, hopefully you get 0.12. And then we'll finish off with a harder question. Well, what's the probability of getting under 14? So this one here is going to be a bit trickier. So same thing, I'm going to write probability of under 14. The same approach, it's still F over T. There's still 25 combinations, and we now need to figure out how many of them are under 14. So if we have a circle of our graph or our table, we can see all of those ones that I've circled, they're under 14. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 19 of them will be under 14. And that there comes to 70 or 0.76 when you convert that to a decimal. So hopefully you found this video useful. So what we did is we tried to look at how to use a table to answer questions in relation to probability questions. We then had a look at something called the sample space, and we then tried to use F over T to find the probability of these harder events as well. Thanks so much for watching, guys. Now let's get into heaps and heaps of practice.